Hello and welcome to the last part of the procedural stairs. And in this part we're going to do unwrapping of the model. Before I start, in here I also added an extra parameter to control the height of these handles. Before it was quite low, and if someone would walk here and would like to grab the handle, this would be pretty low. So I also exposed a parameter to control the height. So now we're gonna unwrap the model. And we will be doing this based on a trim sheet. So I've mentioned this before. And my texture trim sheet looks like this. So I have a couple of details here and there that I can use on my model. So you can definitely make your own trim sheet or make something similar. So the system should be very easy to adjust if you want that. Now the main idea of this is we need to go here where we created the sweep, this shape. And I've talked about that we can actually generate UVs here already. So in here I temporarily disabled the grid and we can see that everything has already been unwrapped. So it has a decent unwrap. So if you want to double check this, we can, for example, use a quick shade and it will automatically then show the version with the UV checker on it. So it already has some basic UVs going on. And I will be using this feature in the sweep for automatic unwrapping. So before we're gonna do the sweep node, I want this piece. I want to make a calculation between the sizes. I want to know how long each line is and where it should fit on my trim sheet. So let's zoom in on this piece, for example. So if I have here these smaller primitives, they should definitely be going here on the smaller parts where we have some detail. When I have some larger primitive, like this one, we should then, for example, place it here where we have a larger space to place this on. So I want to build a system that based on these length of the lines, we should then sort out these values. So after the symmetrize, we're going to build a system. So make some more space here. And what we will do is we will use the convert line. So I've used this before. And if you remember correctly, this will make from each line between points a primitive. So here everything is just one primitive called 0. And in here everything is just separately a primitive. This convert line gives us also one big advantage. It automatically calculates the length of each line. So this is stored then in the rest length. We can also check this information by going in here to the sprite sheet. And if we go here to primitive, we can then see how long each line is. So we can use this information to then sort out our primitives. So values that are, for example, bigger than 0.5 will be placed here on these big trim sheets. And the values that are, for example, small, like 0.1, they should then have UVs placed here around these smaller details. So this is the main idea of the system, is by using these distances of the lines. Then what I would also like to have is I want to know what is the longest edge by default. And we can do this by using an attribute promote. Now in this attribute promote, what is the most interesting feature that I want to look at is the promotion method. We can then here say the maximum value. So there are more options here, but I'm mainly interested in the maximum value because I want to know what is the largest primitive. So I want to put this on maximum. Then I want to fill in the group to look at. So in our case, it's the group from here, so this one, rest length, and this is also stored in primitive. So if I would click this icon here, it doesn't appear here because we are looking into the points. So I'm going to change this from points to primitive. Then when I click this icon again, we now have the rest length information. Now this information, I want to store this then in the detail. So right now it's stored in the points. And you can see that it's not really working. It's not really showing the highest value. It's just converting the information from primitive to points. It's just showing the highest value per point. So we say new class and we switch this to detail. So now this is gone, and if we go here to the detail view, we now have the maximum length, which is 3.6 in my case. So now we can always ask what the maximum length is of my model. And I also want to change this name, and I'm going to call it maximum length. And I don't want to delete the original. I want to keep the original information. So this node is mainly used to get the maximum information, to get the maximum length. Because this information I will be using in vex. So the next step will be indeed placing down a wrangle node, and we're going to use some vex. So if you would not be familiar with vex, don't worry too much. It will be quite simple and basic knowledge. And in here I'm going to create some codes to sort out values, to sort all the values. And I want this code to run over the primitives. So the reason why I want to run over the primitives is because I have here in the primitives, I have stored all the length values. So it would be easy to then control them and sort them here. So here, setting this to primitives. Then I want to make a variable that contains the current size that has been fit to 0 and 1 range. So I'm going to make a float. I'm going to say current value. This equals to from the rest length, so the value we have here. So how we can ask this information is by saying add. This is the name of the attribute you want to access. So if you want to access point, you would type in P. If you want to access color, it's CD, and so on. So in my case, I want to say add the rest length. So now we are just equaling the rest length to the variable here, current value. But I want to divide this value by my maximum. So by the maximum value that I've calculated here. So I would like to have the information here from detail. So these 0.3 and so on. And the way that we can ask this information. So we want to divide the maximum from it. And we're going to say, first of all, we are currently looping over primitives, but this is stored in detail. So we have to say, look into the detail attributes, then we say in 0, then we fill in the name. So in my case, max length, and then we have to fill 0 back in again. So if you fill this in, this should then work. Also, if you would be wondering what certain values mean, it's always a good idea to quickly check the documentation, and here it's nicely structured on what's going on. So the first 0 means which geometry, so 0 means itself, then attribute name, so in my case max length, and then the last one called ignored is 0, and then you can find out more information here about ignored, so it's just there to change the primitive call. So documentation, very useful on how to use certain functions and so on. Now maybe you want to double check what's going on. So let's view this also here in the geometry sprite sheet. So how we can simply print something is we could show this in the geometry sprite sheet by typing in f for float, add, and then you can give it a name like print value, and then we equal this to the current value, something like this. So here we then printed the value, and now we can see that my maximum length is 1, and then the other values are then nicely scaled between 0 and 1. This is done in case you would have, for example, a way bigger size here. So now you scaled the size to an equal 0 to 1 range, which can then be used to filter out values. And I'm going to remove this line here again. It's just if you want to quickly see what's going on, you can always print out this value. What's next is I'm going to create an if statement. So here we're going to define which part should be included in a certain group. So if my current value is, for example, smaller than, let's say, 0.3, then we are going to color this for the moment, just so we have a visual representation. And I'm going to take color red. Now I'm here back in my scene view, and what I can see is that these small parts are now being colored red, and that's exactly what I wanted. So I've sort of like sorted or filtered these values, and I can select now specific parts. So the small parts can now be separately selected. So based on this value, so if you would go higher, you can see that then certain parts are then also included. So this is hard-coded in the code, so I have to always get in the code to change what's going on in the viewport. So I want to expose a value that I can have a slider to then change these values. So I will make some space here, and we're going to make a sorting value. And in here I want to then create a parameter. So this parameter will be a float, and in the code here I will call this sorting value number 1. And this equals to channel, so ch, give this a proper name. We're also going to call it sort value 1. So now we have created a parameter in the code. So if I click this button here next to the code, it will check the code for these parameters and it will create them. So we can now have the slider right here. So by default, it's going to make a float. If you want to, for example, make an integer, you will have to type in chi, and this will then create an integer slider. So if you would click here again, it won't update. First, we're going to delete all the spare inputs and we're going to recalculate them. And now you can see that it's an integer slider. So there are of course more variations on these, like V is for vector. You can also make ramps and so on by using the code. But right now I'm only interested in using a float slider from 0 to 1. So this float here, I'm going to copy paste this name and I'm going to replace the 0.1 with the sorting value, which is then here my slider. And now I can, based on this slider, as you could see, select certain parts. So I can say everything that has a red color will then be placed on top, for example. So if we put this in the sweep node, we can see that it also has colored these parts in the red. So we have this information also usable here. So the sweep will keep this color information and also the other attributes so we can use them. So this is then the main ID of this node, of this code, is to sort out values. So I'm going to repeat this process to then also have bigger values. And in here, I'm going to make a second value that we can also use to filter our values. And I will here make another if statement, and I will use the else if, and then use current value. So if it would be bigger than my sorting value, and if it's smaller than my second value. So here, number 2. And then here these brackets again. And I'm going to give this the color. And I'm going to give this color green. So if the current value is bigger than sorting value 1, so in here we checked if it was lower, so if it's bigger than sorting value 1, and it should also be lower, so I'm going to switch this, then sorting value 2. So it means that if the current value is between 1 and 2, it should be green. Then if this value, if current value is still bigger, then I'm going to use the else, and then we're just going to color it in blue. So if values are quite big, we're going to color them blue anyways, and accept this. And here I have to click this icon here again to have my second value. So right now everything is colored blue, of course, because it's going to skip this, because this value is 0, and it's going to automatically color everything in blue. So if I would increase this bigger than this value, we can now have like a third color, which is the green one. So as you can see, so in my case, I have 3 sorting options. So small, medium, and large shapes. So you can build a more complex system to sort out more, but for the moment, I kept this system simple, so it should be understandable. Once this is working, I'm going to do one more thing. So, and I will store this in a new attribute, and I will create a new attribute here by saying f at an index length is 0. So this is for the small shapes. So this will be the small shapes. Then here index length will be 1, is the medium shapes. And then the last one here, index is then number 2, and this is then for the larger shapes. And then now the code is done. And I will also rename this wrangle to sorting. So that's it for this part then. And let's look how my sweep is looking. And we can notice that something is actually off of my sweep. Some of the polygons are actually now being reversed. And the reason why this is happening is because of the convert line we did. So we made every single line a primitive, and the sweep doesn't recognize the correct directions of primitives anymore. So some primitives are flipped. Let's fix this issue, and first of all we need to fuse together everything, because of the convert line, everything is actually now, as you can see, separated from each other. So I'm gonna fuse all the pieces together, and then we're gonna use the polydoctor. And with the polydoctor, it can check on if polygons are flipped. So here, if you go to topology, we can use the correct winding of polygons. And now it has flipped them all reversed. So I have to reverse it once more again. And now it's showing up correctly. So all the pieces are also now together. Then I would also go back up here, And I would love to have an attribute. So I'm going to use attribute create. And in this attribute, I want to store the primitive number. So because we are going here, because of the sweep and the fuse and so on, so I'm gonna call this prim ID. This is stored in the primitive. So we have here prim ID now. And this can be an integer because it's just a number of primitive. And then we can say add prim num. So if you fill this in, you can see that my prim ID has now the same number here as my primitives. So if you plug this in here, you also now have afterwards, after we did all the fuse and the polydoctor, you still have access to prim ID, and you can see that there are now more of the same IDs, and we can call this group now to then unwrap it apart. So in here, I'm gonna do a for loop, and I'm gonna do for each name. I'm gonna do the for each named primitive. And maybe you have guessed it, and in the for each named primitive, I'm gonna use the prim ID I just made. So that means that I will be looping over these pieces separately. As you can see here, I'm looping over them one by one. And notice that the color are always the same of each loop. So in loop number 0, it's blue, 1 green, red, 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 blue, green, and so on. So this makes it a bit easier to then now unwrap this. So if I would go down to my unwrap and place down a UV transform, the first thing I want to do is rotate my UV 90 degrees, like this. Then the second thing, it would be nice to also have my trim sheet in here. So press D to open display options, and we can go here to background. And in here, we can go to UV and set a background picture. So load in the picture you have from the trim sheet. So in my case, I'm gonna load the trim texture and the normal. And we can also here boost the brightness of the texture. So now I have this picture that I also had here, and I can simply place this where I would like to see it. And so this is the blue part, which means it is the biggest value. So we can zoom in and then fine tune the UV spacing. So this is then the UV for the large pieces. Then if I would go to the next part, which is the green part, and this should then be the UV for the medium pieces. So I will be copying the UV transform and change the name to medium. And now I will move this piece to then the detail I would like to have for my medium pieces. So maybe let's take this part and let's scale this down so it's now covering this piece. Then I want to like to have a red piece, so I will move the path here, and I will do the same process, copy the transform, and now I'm gonna call it small transform. And here I want to like to put my UVs on these smaller informations, like so. So that's set up, and now I want to disable the single passing again. And I would like to build in a switch node that switches from these UV nodes based on what the size is. So switch. My first input will be small, then medium, and then large. Then, if you remember correctly, we saved here a attribute that is called index length. So I want to use this index length, so I'm gonna Control C this, and I'm gonna use this value in the switch node. So if we have the small size, it's going to turn 0. If it's medium, 1. If it's big, 2. So this value is very useful in my switch node. So 0 will take the first input, 1 will take here input 1, the middle one, input 2 will be taking the largest one. So we have to ask this attribute, and this attribute is stored in a primitive. So I'm going to type in prim 0.0 index length, which I copy pasted, and then once more 0 again. And now I can already see it working here. We have a system that switches automatically between the size of the UVs. Now, to see this also then in our viewport better, let's take the quick shade. And in the quick shade, we can sort of see that our UVs have now a very specific layout. And let's fill in here our image from the trim texture. And we can see that we have now properly unwrapped this model based on trim sheets. And I also don't need the color at this stage anymore. So if that would be bothering you, I would ask delete attributes, and then we can simply then here delete color. So we have now unwrapped this based on trim sheet. We actually need to fuse back the pieces because we looped over individual pieces and the loop separated the pieces. So we have to fuse this again. I will keep the quick shade node on the side, so if you want to double check what's going on, you can always use quick shade node. Then the last part here, let's make some more space, and let's bring this piece down so it closes this part, and also here beveling this piece as well. So, but these nodes doesn't include any information about the unwrapping. So if I would plug this in here, you can see that there is something weird going on. So that's not nice, and I would like to have something better. We can use a split node here for a moment, and in this split node we can then split based on the patch group. And now what we can do is I would use a loop. So we have two pieces, the beginning and the end, and I would use a for each connected piece. So it means it will loop 2 times because we have 2 separate pieces, so the beginning and the end. And I want to unwrap them procedurally, and I'm going to just use the UV texture node. And in this UV texture node, I'm going to set the axis to the z-axis. And what it does by default, it will scale automatically my 3D model to a 1x1 in UV space. So it's stretching this a little bit to fit in the 1x1 space. Then after this loop, we have then this information, and I'm going to do a UV transform. And with this UV transform, I can then here place this where I want to have it. So maybe we can scale this down, bring this somewhere here to a detail you'd like. Maybe here, so we have some details here going on, and these details. And then I would like to merge this final result back with this result. And let's see how this is looking. So now we have here a better ending. And based on this information, as you can see, I can then choose the trim sheet information I want to see on the ending. So that's some nice control you have. So it's still working procedural, but I have control in where my UVs are on the trim sheet. So that's a bit more manual placement. But because we are using a for loop, we don't have to individually do each UV element. We then just do all UV elements in just one big loop. And that's it for this system. It got a little bit bigger here for the procedural UVing, but it's definitely worth it with what we have. One more thing I didn't talk about in the other video is, let's say if you want to have a collider, we can then use a group node. And in this group node in here, we're going to type in rendered collision geo. So by typing in this code, it will create a mesh collider for this piece. So there are more options to create custom colliders, like you can create box colliders and so on by using groups and filling in these names. So I've used this also in other videos, but in here I'm just using a full mesh collider for this part. Then I'm actually going to repeat the same process I did here for this part here. So this is then also unwrapped based on the trim sheet. We can copy paste our system that we just made and use it then for the other part as well. So the system is made in such a way that it's quite flexible, and I can now copy paste these nodes and copy paste them here as well underneath the transform and plug it in here. And now we should be able to also see the same results where we have these colors representing big shapes, large shapes, and medium shapes. Then going into the wrangle node, we can then here tweak where shapes should be. So in here, I want to increase this value a bit because I would like to have more of these red values. So something like this would be great. And here after the sweep, we also need to do the same part. So I'm going to select all of these nodes until diffuse and copy this here as well. So a few things I notice. First of all, my mesh seems to be reversed. So that checks what's going on. So first I fuse everything together. Then I do a poly doctor, and I can see the poly doctor has effect on the blue here, because now it's blue. Now it's like the flipped polygon. And then I reverse it back. So in this case, I don't need to reverse. So it would be possible to either build a safe system to reverse if needed, but I'm quite confident that this will hold. Then I've also noticed these small warning signs here on my UV transforms, and let's show the warning. So it's saying missing UV. So this means it doesn't have UV information. So if I would go back to the sweep, and if I go here to my UV tab, I didn't enable calculate UVs. So I enable UVs, switch to my UV viewport, and I have now my UVs. So if I would calculate this again, we can see that our UVs are now placed where I would like to have them. Then we can also copy paste the quick shades, Ctrl C, Ctrl V, so we can see what's going on. And I want to change actually these transform values so we have them placed better. So in here, we can then make the decision to, for example, move this to this part. And we can make the medium, for example, this part here. And this is then now the result. So we have used the trim sheet to unwrap this as well. So by just copy pasting the nodes, my system already works. So now we need to make some more room here and plug in plug this in here. Then also for the handle, you could also build a more advanced system, but in my case, I'm just going to go here in the sweep of the handle part compute UVs. So we have the UVs. And then I will do a UV transform. And with the UV transform, first of all, rotating it 90 degrees. And now I can say where I would like to have it on my trim sheet. So maybe the handle part will be more like this, something that doesn't have too many details. Or if you have a specific part for your handle, you could then place it there. Let's bring the quick shade here and let's view my model. And this is also nicely then unwrapped. So here's then the result, and if I switch to my UV, we can then clearly see that everything is nicely aligned on these trim sheets. Before actually opening this in Unity, there is one more thing we need to do. So I noticed while making this tool that sometimes there might be a conflict here with this sweep. So what could help here is after the symmetrize, we need to do a flat edges. Dissolve flat edges. So this helps with the system. So if I save my asset now and go here in Unity and rebuild it, we have now our correct look of the stairs. So you notice that I also added these lights, effect and so on. So you could do that as well. So that's purely on the trim sheet. Because then I have an emissive map here that has some light. So let's disable the bend for a moment and let's see the trim sheet in action in Unity. So if I move my curve, you can see that in real time we are changing our trim sheet and our UVs. So if I have a smaller version like this, notice that we don't take as much space as if I would, for example, do this, where you can clearly see that it is properly looping, tiling on the trim sheet. So that's pretty cool to have, is to have a system that does this procedurally. And then afterwards we can then always bend the model in the direction you want to. So this tool is almost finished. One more thing you could do to polish this more is to add more parameters here. So I might skip that part a bit and I will show you the result. So here is my stairs with some extra parameters. As you can see, I've added UV settings for the support and also for the steps, so we can fine-tune a bit more the UV and the sorting values. I've also here added support for the lights. So on my trim sheet, I have a part that is emissive. So if you want to have certain lights, you can then have that, but if in some case you might not like that, so we can toggle this on or off. Then we can also here have, for example, a stretching value, so we can multiply the current UV, and then maybe in some case you want to manually fine-tune some of the placement until you're happy with it. So that could be possible. Also here, same settings here. Like you can, for example, increase more lights, and we can play around, as you could see, with these sorting values, and these decide where UV should be on the trim sheet. So in this case there are way more lights now going on, but I like the one light over here, or if you put this low enough we just don't have lights at all. That could also be nice. So in general what I did is I went here to the sorting values and I exposed these values so I can control them in Game Engine. So that's great to have also there. Then also here with these UV transforms, in here I multiplied the stretch value, so we can stretch it a little bit or fine tune it. And also here for the lights I have a switch node So I can switch between this result or this result. And you can build and you can keep building on this system where you have a lot of settings in Unity to then say which UV shell should be placed where. So we can build multiple variations in your tool, so each time you have something different to choose from. So in this case, a switch node is really useful to then, for example, have this information or a certain information here. I have also reworked some of the collisions. So in here, I have now splitted up this part, and we can use this as our collider. We can further optimize this if you would like to. So also here there is now a group node. So this contains all the information of this part. And when we bend the model, I would also build a new custom collider, which will look like this. So what I did here is, first of all, we have the bend result. Then I extracted this support piece. Then I made sure we fused small parts together, and then I decided to polyreduce this. So to make sure we are not using too many polygons. And then I added this to the collision geometry. So it is possible to build a procedure system that generates colliders for you. Then here back in Unity, I have built some variations on the stairs, just to show you that it's quite easy to build multiple variations to make for your level. And they are all using the same material, so they are all using the trim sheet. So it's really nice to have that also. So if you were wondering on how you could bake results, we have here baking options like bake in game object, prefab, and we can also update prefabs and so on. So often here it would store information in the baked folder and make, for example, here a prefab out of it. So that was it for this tutorial. I hope you enjoyed it and thank you for watching.